This video covers net present value, or the time value of money. The problem with break-even analysis or even decision trees is they don't account for the time value of money. That over time, money is worth less because of inflation and other factors. So if there is money due me, I actually want it sooner rather than later, because the longer I have to wait for it, it's worth that much less in today's dollars. Now, if I'm paying, I would want to pay much later that amount in today's dollars because it's actually less in the future. And so we want to take that into account, and net present value allows us to do that. And so I'm going to use the data from 7.34 from the supplement. What we're looking at is we have two options here. We have a set of small ovens, 3 of them, or 2 large ovens. And looking at the data, we actually have pulled the cost. Now, there's 2 ways to do net present value, kind of like what we did with decision trees, in that you have to determine whether it's a cost model or a profit model, a revenue model. You can do net present value both ways too. This one looks at cost, and so we want the one with the lowest net present value cost. So everything, all these costs discounted back to today's dollars, and what is the lowest amount. We could also look at this from a revenue standpoint. In that case, we would want the highest net present value. So keep that in mind, whether it's a cost or a revenue model. And so what we've done here is we've looked at, now this doesn't include the initial cost. We'll take care of that later. Basically, that's year 0. And so that is a cost that we do not want to discount because it was in today's dollars. But we want to look at the ongoing cost. And for the 3 small ovens, they have $750 for labor and another $750 for maintenance or cleaning. And so that adds up to $1,500 per year. So in year 1, year 2, year 3, year 4, and then year 5, we have an interesting circumstance. In both cases, these ovens, the 3 smaller ovens or the 2 larger ovens, are only designed to last about 5 years, and they'll need to be replaced. And so there's a salvage value. We'll be able to actually sell these 3 smaller ovens for $750. And so you'll see that I've reduced the cost. So instead of the $1,500, because we'll actually sell the ovens and get some money back, $750, our actual end of the year cost is $750. Now let's turn over to the larger ovens, the 2 large ovens. There is no additional labor, and you'll see the maintenance goes way down. But you got to remember that high initial cost. It's a much more expensive option initially. But over the ongoing is much lower. It's just $400 for cleaning and maintenance. The year 5, what's interesting about it is the salvage value. There's a much higher salvage value, $1,000 for these larger ovens. And so in some sense, we go to the positive. So I actually have entered these in the way I have. So this is a negative 1,500. And that's important to do when you're doing net present value, to recognize inflows and outflows. In this case, this is an outflow. And we can actually build in there the inflow. So yeah, it costs us $400 in year 5, but because we got 1,000 back, we're actually up inflow of good of $600. And so by doing it this way, keeping track of the negatives or the outflows and the positive, the inflows, this works very well for revenue models as well, because you can keep track. Sometimes with the revenue models, there's ongoing costs associated with those, and you just put those in as negatives and recognize the. But we're basically looking at the end of each year and what is the outcome, given the inflows and outflows, and what are we left with. Okay. We're now able to do a certain amount of discounting. And so what I'm going to do is I'm going to use the table, and then I'll show you how to do this in Excel. On page 303, you have a present value table, and they have figured out what percentage based on the discount. So across the top, you have the different discount rates. We're using 14%. They told us that's the interest Oftentimes this is a good substitute for inflation because the banks have kind of figured out if you borrow money from the bank, they figured out what the inflation rate is to kind of keep track of that and other things. And so sometimes this is a very good substitute for it. And so we're going to use that. So we're going to use that far column. And in year one, so I'm going to just write these amounts over here just so that that I have them. You have a 0.877, 0.769, 0.675, 5.92, oops, 0.592, and then a 0.519. So these are the discounts. So what we're saying here, based on a 14% interest rate or a very heavy, we're only going to consider 87.7% of this value of this cost because we got a whole year to pay it. Over that time, it's really not 1,500. It's only 87.7% of that. So we can actually calculate this out then. So we'll take this amount and we'll times it times this rate here. Now we can actually then copy these down. You'll see, so instead of 1,500, it's only $1,315.50 because we had until the whole end of the year to pay that. And so we will discount the others appropriately. So look at this year 5. It's only 51.9% of the value. So because that $750 does not have to be paid until the end of year 5, really in today's dollars, that's only $389.25. So now it makes much more sense to then sum up these costs. We could have done that over here, but that would just be as if we didn't take into account the time value of money and just treat these all as if full value. But we want to sum these up because these are the discounted amounts. And so I will sum these up, and then we will get that. Now remember, you also have the initial purchase price that we have to account for here. So going back to the data from the problem, the initial purchase price was $3,750 or $1,250 each, and there are 3 of them. And so we will subtract that. And so here then you have then once again the cost over the 5 years plus this initial purchase price at full value. So once again, this is adding these two together. And that would say that the net present value or the cost of this is $8,508.75. So let's kind of compare this just so you have some idea. So here's is if we didn't discount those factors, what that would add up to. And then of course you have the purchase price that is not discounted in either case. Because that was paid immediately in today's dollars. But you can see the difference here. If we don't take into account the time value of money, we would say this is $10,500. But in reality, because it's paid out over 5 years, it's $8,508.75. Now let's do the same thing over here. So we're going to take these costs, the $400, we're going to times it times the discount factor that we looked up on the table, and we will then copy that down. We'll make sure that it's doing it correctly. So let's double click on this one. Yeah, it took this amount and discounted by the appropriate one. And so you'll see here, remember we had a positive because our salvage was greater than the cost of the $400. We got $1,000 in salvage, so we actually got $600 inflow. But in reality, because it didn't happen until year 5, it's almost worth half of what it in today's dollars. But once again, we could we'll do this in both cases. We'll treat it as if we did not account for the time value of money. This ends up being $1,000. This one with a time value of money, In reality, this only cost us $853.80. And so we can take into account now the purchase. Here's where you kind of get the difference. Yeah, we can see that the costs, the ongoing costs are of course lower, even the discounted and even the total without the time value of money, but we're concentrating on this discounted factor. So 4,758 and this 853. But remember that this is a much more expensive option. This is $5,000. Let's put it in as a negative but we do not discount that at all because that was paid immediately in today's dollars. And so that's why we didn't include it up there and use any kind of a discount factor. And so we can sum, this is the time value of money, or without the time value of money it would have been 6,000. This is what we really want to know. What is it with the discounted amounts? And so we wind up with 5,853. Now, like I told you, this is a cost model, so we want the one with a lower net present value. And so we should go with the larger ovens, taking into account the time value of money. It is the cheaper option. Now, I want to show you quickly how to do this in Excel. You can do this in Excel. There is a function built in. It's called net present value. You put the equal and NPV, net present value, parentheses, and what it wants is the rate. So we can plug in the rate here. They want it in decimal format. So 14% is 0.14. And then they want the values. Now, here's the critical thing. You need to take these original values, and I don't want to include year 0 or the purchase cost because otherwise Excel will say, oh, that's 6 years worth of data, and it will actually discount the purchase. And remember, we don't want to discount that. So we're going to just discount those values, and so we'll automatically apply the appropriate discount to each one of those. So the first one would be 0.877 and the second one, so it's doing it for us, all built in this function. Now you'll see that they're a little bit different because basically this value is this value, and then we would then of course have to subtract the original amount of the cost of the oven, and so then if we were to sum these up, so that's an outgoing. I guess we can format this properly so that you see that. So it's showing up the same way. We'll go ahead and do that. So that's a negative amount. Oh, I have it formatted slightly different. I have it formatted this way. There you go. So it matches. So you'll see that it's slightly different. The difference has to do with, you notice in the table we're only carrying 3 decimal points. Excel will carry a lot more of that. So by using this, they'll be slightly different, but they should be in the ballpark. Now we can do that same thing over here. Let's do it again, equals NPV. We're using the same discount rate at 0.14, and then we would discount these amounts. Remember the original amounts. And look at that, really close, so 6 cents difference. And then of course, like we talked about, you have the 5,000 initial negative. Let's, I guess, change the formatting here, there. And then if we add, so our discounted amounts plus this amount here, our initial purchase price, we wind up with 5,853 and 86 cents. Once again, due to rounding errors, net present value will be a little bit more exact. That's how you do net present value. I'll talk about in class how to do it a little bit differently if your amounts are exactly the same. We can use what's called an annuity table.